So, okay, in our last video, we looked at this question here and we looked at how to use our calculators to find this region. In effect, what we are finding when we do this is we are finding what's known as a definite integral. So this symbol here is the integral between -8 and 4 of x squared plus 17x plus 106 all over 2x plus 11 dx. Okay, that is how we write this out in maths. And it will find the area between the curve and the x-axis between the two limits we put here, i.e. the line, x equals -8 and x equals 4. And that obviously came out to 56.6. Now, there's a word of warning when using the calculator to find this. Okay, we're going to now look at a different question. We're going to look at this function. We're going to look at y equals x minus 1 between the points where x equals 0.5 and x equals 2. As you can see, let's just go back to the menu 5. I've already put the function in and I'm going to draw it. So here's my function. Then I'm going to go to, like last time, I'm going to go to graph solve, go to this F6 button, and we'll do the integral again. So I've got to press integrate. I'm going to put my lower limit of 0.5, or lower bound, and my upper bound of 2. And it works out the area. So it says, calc says that the integral, okay, of x minus 1 between 0.5 and 2 is equal to 0.75. And that is correct. That's what it's worked out. But what I want to do is, we'll notice this as an area below and above the axes. Okay, there's an area above and below the axes. And what I'm going to do, we can see the graph crosses at 1. It's obvious it crosses at 1, it crosses at 0 from the factorization here. I'm going to find this between 0.5 and 1, and I'm going to find it between 1 and 2. Let's just go exit and let's draw again. Let's do graph solve. Go here. I'm going to put my lower value of 0.5. I'm going to put my upper value of 1 in. And what you see is if we do from 0.5 to 1, we get minus 0.83 recurring. Let's just do graph solve again and put our lower limit now of 1 and our upper limit of 2, and we get 0. So from 1 to 2, we get this equal to 0.833, so 83 recurring. And what you can see is if we do this one plus this one, we get this value. This value is negative. So actually, it's not the total area between the curve and the x-axis. If we just copy that sketch onto here, what we have is we have this area here, and we have this area here. So there's 0.5 and there's 2. What is happening? Those areas are cancelling out. So actually, the total area is going to be equal to 0.83 recurring plus 0.083 recurring. Okay, and if we do that, let's put that into our calculator. So do 0.8 plus 0.083. And you can see we get 0.916 recurring if we do that properly. Okay, obviously, because I've already just typed in some of the numbers, I get a truncated answer, but this would be my exact answer. So when doing curves across the x-axis, you have to be careful if you're trying to find the total area. So identify where it crosses the axes, integrate from the low value to the crossing point, and then integrate from the crossing point to the upper value. Get these two values and actually add the magnitudes together. Make this positive and add it to this value to get your total area. Just a reminder, when you have a curve that crosses the axes, you need to split your integral up into the negative parts and the positive parts and work them out to get your total area between the curve and the x-axis.